Before we begin this Microsoft Digital event, we would like to acknowledge the traditional custodians of the land on which we live and work throughout Australia, as well as the Aboriginal and Torres Strait Islander people viewing this event today. We pay our respects to elders both past, present and emerging, and recognise and celebrate their continuing connection to land, waters and community. Our reverence also extends to all First Nation and Indigenous peoples, as well as their ancestral lands.
Welcome to this Microsoft Digital event. Before we get started, there's a few things we wanted to point out so you can make the most of this experience. Firstly, the windows you are seeing can be resized. You can maximize, minimize, and drag the windows to the size you prefer. You can also use all the widgets in the bottom middle of your screen. Simply click on the widgets icons to launch them. Secondly, we have specialists on hand to answer your questions in real time. You can type in your question using the Q&A window at any time during the event, and we'll answer them as soon as we can. Lastly, you can access additional resources by clicking on the links in the resources section. We hope you enjoy this Microsoft Digital event. Let's get started.
Hi everybody and welcome to New Breakpoint. My name's Simon Waite. On today's show we've got a cool topic about a subject that I know that's going to be of real interest to you, and I know it's of interest to you because you've registered to show up today, but we'll get to that in a moment. If you do have questions about the topic we're covering today, please make sure to use the Q&A window in Teams to put your question in during the show, and we'll either answer it in real time while the show's going, or we'll get to it during our live Q&A at the end if it requires a bit more exposition or discussion, or it's an interesting topic that a lot of people seem to be interested in. If you do want to share today's content with your colleagues or community, keep an eye on your inbox. We'll send you an email a couple of days after today's show with details on how you can get access to the video. And as always, the show notes will have the details where you can go and find additional information, access demos or GitHub repositories as well. So today's guest, friend of New Breakpoint, Todd, is back again, and this time he's going to be talking to us about how you can use container apps and Dapr to take away the pain of working with Kubernetes. Now, I think we've probably all heard a lot about Kubernetes as a technology that's revolutionizing the way we host and run our applications, both on premises and in the cloud, but it does come with a fairly steep learning curve, and not everybody's got the expertise or depth in their teams to want to have to manage Kubernetes. And in fact, as developers, why should we have to manage more infrastructure? Well, today Todd's going to show us how we can achieve the nirvana for developers of getting the best of Kubernetes without the need to actually manage Kubernetes. So let me get Todd on and we'll have a quick chat about his topic, and then we'll be on to the talk. Welcome to New Breakpoint, Todd. Good to have you back.
Awesome, Simon. Great to see you again.
Look, I talked a little bit about what you're going to cover today in my intro there. Do you want to tell us just a little bit more about it? Maybe tease us a bit what you're going to talk to us about today before you get into the demo.
Yeah, absolutely. Look, as you said, it's really about looking at some new options for developers when they're building microservices. As you said, Kubernetes is eating the world, and it's awesome and it's powerful and it's complex and it's sometimes needed and sometimes not. But unfortunately, it's been something where we haven't had a lot of choice. So today we're going to see that maybe we do have a new choice.
All right, so let's get into the demo. I'm going to hop off the stream at this point, and Todd's going to take us through the next sort of 30 minutes or so. But I'll be back at the end of the episode for the live Q&A, so please do hang around for that. And Todd, over to you for the rest of the show.
Awesome, Simon. Let's go.
So it does feel a little bit like, for the last few years anyway, no matter what question you ask when it comes to software development, Kubernetes is the answer. And Kubernetes is an awesome orchestration platform. It enables all sorts of really interesting and challenging problems. But like all good software solutions, it comes with its own challenges. So today what I'd like to do is just spend a little bit of time looking at how we can leverage the power of Kubernetes without necessarily taking on all the complexity that goes with it. So before we do that, just to take a little step back, just into the broader context of where we are with software development in 2022. There's lots being asked of developers. We're being asked to deliver not more code, we're being asked to deliver a lot more value to business. We're being asked to deliver it faster. So not just in terms of the entire delivery time frame, but delivering it in incremental chunks. At the same time as going faster, we need to make sure it's secure and reliable. And in addition to that, we need to build it for scale. So that's not just in terms of going big, but also in terms of scaling the application to the demand it's experiencing. And finally, we're being asked to take all that, learn things from it, and adapt and change quickly. And to do that time after time in a sustainable way. So really the dominant approach to this in 2022 is the entire cloud native philosophy and approach, right? So there's a whole lot of definitions of it, but ultimately it's about, packaging up things in smaller and smaller chunks, using more and more platform services, and then wrapping that with some DevOps processes and culture so we can deploy these things reliably and quickly. So technologies like containers, Kubernetes, serverless functions, API management, all those type of things are the foundational pieces that power cloud native architectures and development. But behind all that, to me anyway, is really a desire to minimize some things, particularly complexity. In order to go fast, in order to make things reliable, we don't want them to be any more complex than they need to be. And that's both at a platform and an operational level, as well as actually at a coding and architecture level. We also want to minimize responsibility. We don't want to be required to do anything if there's a better solution for it. Now that might be things like platform as services, that might be using open source libraries, whatever it is, we want to make sure that the things we are building, the things we are responsible for, are things that actually relate to our business problem and delivering value for the business. We want to minimize friction. So we don't want to create, processes and things that slow us down from building this software and delivering it quickly. And we're also, with the pace of software development and cloud services, we want to minimize the use of one-way doors. So we want to make sure if we choose to use service X and tomorrow's service Y comes along, we can switch to that without a whole lot of rework and overhead. So there's some kind of underlying principles I want us to keep in mind as we go through this. So before we even think about a Kubernetes style approach to using these services, let's take a more simple example. So if you go to the Azure architecture site, for example, you'll see this architecture, a very simple serverless microservice architecture, right? So there's no Kubernetes here. This is API management, it's function apps for serverless things, we've got Cosmos database, we've got a whole range of Azure platform services we're using to make our life easier. So on the surface, this kind of meets a lot of those criteria. And it's a really lightweight, fast, easy way to get going with a microservice architecture. But that simplicity also comes with some downsides. So although these services provide the functionality we need, in terms of overall management and orchestration of the pieces of this architecture, that's really up to us to do. So for example, if I'm going to deploy a new version of my API as a function app, I might leverage some of the functionality in Azure API management to create a revision of that API and publish that. But I need to write the code that does that and orchestrate that across these different services. Right? So there's a lot of effort on my part to manage that overall solution. And if it's a relatively straightforward application like this one, something like a static web app, that overhead isn't significant, and that would be a great solution. Really low cost, really fast. But as our microservice solutions get more and more complex, the burden of that operational overhead and controlling the overall platform increases. And that's where orchestrators like Kubernetes come into their own. They're designed to not only deploy those distributed applications, but also to provide some tools to manage and ensure everything's running as it should. But that really introduces a whole lot of other things to think about. So using managed Kubernetes services like Azure Kubernetes Service, a lot of the base infrastructure is taken care of for us, right? So Azure will provide us with a managed Kubernetes control plane, through the Azure services that will look after the nodes that are going to run in the cluster. So that's all good. But the reality is to have a production-ready Kubernetes service, there's still a whole lot more to do. Okay, so the great thing about Kubernetes is it's so flexible. You really can configure almost everything about it, choose different network planes, all sorts of things. That's fantastic. The worst thing about Kubernetes is it's so flexible and you can customize everything about it. So that means we need to understand yet another layer of abstraction, right? So all the things we were trying to simplify, we now need to think about to create a secure and appropriate environment. And if you go and look at the Azure Architecture Center, there's baseline and reference architectures for how to do that, right? So that's everything from choosing what network stack am I going to use? How am I going to manage IP and DNS aspects? How am I going to actually control ingress into this cluster? All sorts of considerations that need to be thought about, understood, and decisions made. And if you need that fine-grained control, that's awesome. But if you don't, that complexity is something, again, that just gets in the way of delivering the value we've been asked to do. And even once we've got the infrastructure, if you like, of Kubernetes, we still haven't got to the point of something that really is ready for our particular workload. Kubernetes itself is completely unopinionated about how workloads should be defined, configured, and deployed. So at an application level, we need to think about a whole range of things. How are we going to deploy our application? Are we going to push that from outside the cluster? Are we going to pull it from inside the cluster? Are we going to use what are we going to use to control our ingress? So the traffic coming into this cluster to hit these APIs. There's an enormous range of different variations of products and plugins we can use. Azure obviously provides some native solutions, but equally well, Kubernetes allow any of the open source options. So if we run over and have a look at the Cloud Native Foundation, you'll start to get an idea of the richness, but also the complexity of the landscape of Kubernetes. Even just within, say, the service proxy area, are we going to use Envoy? Are we going to use Contour? Are we going to use Nginx? All these things, all these products have different capabilities, some overlap, but different terminology, things we need to wrap our heads around before we can get to the point of building an application. And whether that's us doing that or whether we have an infrastructure team that's going to do that for us, it adds operational complexity. And sometimes that's warranted and sometimes it's not. So if it's not, if we really have a straightforward solution, we want someone to make these decisions for us, what are our options? Well, now there's a new one, Azure Container Apps. The way I like to think about this is it's an opinionated platform. So under the hood, it's still powered by Kubernetes and a whole lot of other open source products. But those decision points have largely been taken for us. Okay, so for example, Envoy is going to provide the ingress and the routing configuration we need. You don't have a choice, that's what you get. It's provided to us as a platform. So effectively, we've removed that. We've traded that complexity by handing over control to the Azure Container Apps platform. And it's really designed around being a productive platform for developers. Okay, it's not a replacement for Kubernetes or AKS. It's another option in the suite of Azure services. So it's really geared around, and you can think about it as serverless containers for microservice. When we provision an AKS cluster, although we might be building microservices, under the hood, we're still scaling and managing it at a node level, at a VM level. And that has cost and complexity implications. You know, someone has to control the cluster to make sure OS patches are updated without impacting the service, for example. Azure Container Apps doesn't have that. What it does have is effectively a serverless container model for apps. So you just pay for the containers that are running. You don't need to worry about how the platform is managed under the hood. It's based on open source products, so beyond Kubernetes itself, things like Kda for auto scaling, which we'll have a look at, and Envoy we've mentioned, and it has fantastic integration with Dapr, which we're going to drill into in a little bit. So really what this does, it allows developers to focus on apps, not infrastructure. Because let's be clear, Kubernetes is an infrastructure solution for building container apps, right? The great thing is the containers we're going to deploy on container apps, there's no special requirement about the container image that we're using. So the same containers that we're deploying onto a Kubernetes environment, we can deploy into an Azure Container Apps environment and vice versa. But beyond just doing that, it also has built-in application lifecycle tasks for a lot of developer and deployment scenarios. We'll see later, for example, things like how do we do blue-green testing? How do we do revisions? All these things that in Kubernetes require you to go and plug in some extra products and learn how they work is built into the solution. So that's the promise of Azure Container Apps. So what can we do with it? So obviously we can use it for microservices, which is what we're going to focus on today. So deploying and managing microservice architectures, straightforward. But it's not just that. You know, it can also support event-driven processing. So for example, if we've got, you know, batch files appearing, we've got messages arriving on queue, that kind of thing, then we can also use it to support that. It can auto scale, for example, to support, you know, web and public APIs. And beyond that, we can also look at how we use this actually for background processing. So all those kind of options are applicable. But let's dive in and have a look and see how it provides a higher level abstraction, if you like, than Kubernetes. So with Kubernetes, we might be thinking about deploying clusters and managing clusters and namespaces and deploying into that. All that's abstracted away from you with Azure Container Apps. So really the base thing we're going to deploy is a thing called an app container environment. Incredibly clever name. So let's say we're going to create that, and into that we're going to deploy our apps. So they're really the two constructs that as a developer we need to worry about. Simple as that. And in this particular example, we're going to deploy a very simple microservice with a front end and a back end container. And just to highlight that, you know, there's no special requirements here in terms of container-based images or language or framework. We'll have our front end being implemented as a Node app and the back end as a .NET app. Trivial example, but highlights the concepts and how it's implemented. So just to make it easy here, we'll create it using the Azure CLI. Like all things in Azure, we need a resource group. Now, all the apps in a container app environment share a log analytics workspace to consolidate all our container logs. So we're going to create one of those, and that's pretty much it. We're then just going to do an AZ container app create, give it a name, resource group, tell it where the workspace is, and give it a location. In this case, Canada Central. And that's it. That's the extent of what we need to do to create the environment that's going to host all these. There is no choosing an ingress controller. There is no configuring namespaces, pod identities, any of the other things we'd have to worry about with Kubernetes. Once we've got that environment, we then need to deploy some apps. So when the environment itself is created, it gets created with a fully qualified domain name. And we're going to see this pop up as we go through and deploy the apps. So in this case, it's created the purple desert name for us. You can see there we're in Canada Central, and then it has the Azure Container Apps. When we want to deploy an actual app, it literally is this simple. So here's the .NET app. We're going to create that, give it a name, and this will become important, put it in the same resource group. Which environment do we want to put it in? We give it the path to our container image we're going to use. And then importantly, we're going to tell it what type of ingress do we want for this. And in this case, this is the back-end app, the .NET app. So we're going to indicate that this is an internal only ingress. Okay, so there's no having to configure Nginx or anything else to manage and define those ingresses. We just tell container apps, hey, this container app, this microservice can only be accessed within the environment, not externally. All right, and that again gives us a fully qualified domain name. So important to understand that within Azure Container Apps, even though it's got a fully qualified domain name, traffic within the environment is not going to leave the network of the environment. We'll have a look at that. And then similarly to deploy the front end, same sort of idea. The only important difference really here is twofold. First, we're going to say that this needs external ingress. This is our front end app. So we need to expose this over a public IP. And equally well, it needs to know where the back end function is. So I've assigned an environment variable which has got that fully qualified domain name we saw before. And that's it. All right, once we do that, we'll get that Node app, which is the name we gave it, and away we go. Once we do that, we can hit that front end URL. We can see here the incredibly complex web page that comes back. And when we click the button, it's actually going to call the back end, which is just going to return a message. So that's accessing it via the front end. Now, if we try and access the back end API directly, right, the .NET app, we're going to get a not found, because that is not exposed externally. Even though it looks like a fully qualified domain name that you would access externally, it's separate. So from a development point of view, all we need to differentiate is, what's internal, what's external. Now, for this example, I've shown it using the Azure CLI because I think it's a little more easier to digest. But obviously, in the real world, we would define these using infrastructure as code. So be that Bicep or ARM or whatever you want to use. That's the equivalent. And then we would typically obviously deploy that using a CI/CD pipeline like GitHub Actions, or away we go. So in terms of barriers to entry for developers to deploy apps, obviously that's an awful lot simpler than what we would have to do if we wanted to deploy a Kubernetes cluster. It's important to remember, though, that even though that was an incredibly simple experience, under the hood, it's still powered by Kubernetes. So the same sorts of reliability, lifecycle management, all the things we would get from Kubernetes is still there. It's just being surfaced in a much simpler way. So we've got those simple concepts of an environment, which is both a network security boundary and a domain boundary. Within that, we've got our container apps. Importantly, though, we also have some really useful things, particularly the concept of revisions. So every time you deploy a new version of your container apps, a new revision is created that you can use. So those revisions basically mean we have an immutable version, a snapshot of that container app. What that means is we can start to do some really interesting things. So for example, we can start to route traffic to different revisions. So think blue-green scenarios or A/B testing. That's all built in out of the box. There's no complexity in delivering that. And if you look in and go in through either through the portal or through scripting, you can see all those revisions are there, and you can simply configure, hey, what percentage of the traffic do you want to go there? So you might use that as a blue-green mechanism. You may use it to gradually transition traffic over to your new version, all sorts of things. But from a development point of view, it's all built in. There's nothing to configure. And that log analytics workspace we created before is shared by all the container apps and revisions in our environment. So that means any container log sent to standard error, standard out, we have access to all of those, even though we don't have access to the Kubernetes infrastructure that's powering all this, we still have full access to our container logs to see what's going on. And when it comes to scaling, we have a wide range of choices here, including both HTTP and event-driven scaling, which apart from being very flexible, support scaling down to 0 when there are no requests or when there's no events to process. Okay, so we've had container apps simplify our platform and our operational side of the equation, but we still need to go and actually build our microservices. We need to find a way to make that easier and achieve these same goals. Okay, and for that, one of the great solutions is Dapr. Dapr, the Distributed Application Runtime, is an open source project. It's portable, runs across any platform, and it helps solve those regular microservice related challenges that every developer needs to solve. Right? So that's everything from, how do we call other services easily? How do we take advantage of all the various cloud platform offerings without having to rewrite or take a direct dependency in our code? And things like, how do we publish and subscribe a message? How do we store state? All these kind of common problems, these plumbing part of microservices, that's where Dapr fits in. So Dapr is provided as a set of APIs, and it runs in a sidecar process right alongside our application. So from now on, whenever we need to access any of these building blocks or services, it's simply a HTTP or a gRPC call, very lightly integrated into our application and can be adopted, as quickly or as slowly as you need. So using the sidecar pattern, Dapr exposes all of its services and capabilities over simple API endpoints. So provided your containerized app can talk either HTTP or gRPC, it can call Dapr without taking any direct dependencies on any of the functionality in Dapr. And the great thing is Azure Container Apps provides a fully managed version of the Dapr APIs and manages and controls all those sidecars for you. So all you need to do is provide some fairly simple configuration and you're off and running. So if we go back and think about our previous example where we deployed to container apps, one of the properties we had to provide to the app was the fully qualified domain name of what the back-end service was. So we had to deploy that service first, get its fully qualified domain name, and then inject that as an environment variable that the code would use. Once we Dapprize our app, all we need to do is pass the ID of that application, which corresponds to the name in our configuration. Once we've done that, we can then access the API wherever that particular app happens to be. And in this particular example here, it's not using any SDK code at all. This is just constructing directly an API. And you can see it's just calling localhost, no fully qualified domain name, and it's just passing in the app ID that it needs to access. Now, there is an SDK provided to make this even simpler, but you don't need to use it if you don't want to. One of the other key features of cloud-native applications is the ability to take care of platform as a service provided by cloud providers. So Dapr helps enormously with this, because not only have we got those APIs, it's a simple configuration change to configure which of those platform services we wish to use. It's still YAML, so we never quite get away from YAML, but the configuration is completely removed from our application. So for example, if we wanted to switch from Cosmos DB to Redis, we don't need to make any code changes, just a configuration change, and the application will keep running using that new service. So if we take the example of state management, we make a simple post call to the state API, passing it a value we might want to store, and it will look at the configuration we have provided alongside the application to determine what state store that will actually get stored in. And not only is it abstracted the configuration, but it will also implement best practices in how to deal with that state store. So error handling, back-off strategies, and even circuit breaker patterns can all be configured outside of the application and reused across multiple stores. So in this example, rather than have any direct dependency on, say, Service Bus as a pub sub provider in our code, we simply provide a configuration YAML file, which provides a name, which is all our app needs to access, and then whatever configuration is appropriate for that service. So there we go. Hopefully that's piqued your interest in both Azure Container Apps and Dapr. Individually, they're great tools to add to our toolbox, but put them together and they represent a fantastically powerful platform for developers to be more successful with building cloud-native applications. So if you'd like to learn more, jump on over to the Azure Container Apps site and the Dapr site. They have great documentation, samples, and quick starts that'll have you up and going in no time.
Okay, I'm back. Awesome talk, Todd. Thank you very much for that. We do have a couple of questions to go through before we get to the live Q&A. And as always, if you do want to get access to the show notes, go and have a look at the debug log, which is there on screen at the moment. Or if you want to see previous videos, you can catch them there as well. Now, obviously today, Todd, you've talked a lot about container apps and Dapr and how, you know, container apps use a lot of open source tech and tech that's probably fairly familiar to those that have spent a bit of time around the Kubernetes ecosystem. So, you know, when we look at container apps, is it really designed to be, you know, that replacement for Kubernetes? You know, should I be doing container apps rather than Kubernetes, or is there a space for both of these things?
Yeah, look, great question. Look, simply, no, it's not designed to replace Kubernetes. I mean, obviously, under the hood, it's powered by Kubernetes and all those other great open source sort of projects and products we spoke about. But it's really designed to give developers a choice. You know, there's times when you need that power and complexity of Kubernetes. You know, you might be in a really highly regulated industry and you need, you know, very fine-grained control over your underlying infrastructure. Or there might be a case of, you know, you might be using Kubernetes to support a broad range of products and applications inside your business. And so therefore you want to share that load and reuse those environments, and you therefore need really tight controls. And Kubernetes is great for that. What Container Apps does give us, though, is I guess a lighter weight, developer friendly option that you can literally go instant on. I've got a production grade platform ready to go, right? Just like you would with Azure Web Apps or something like that, but with the power of Kubernetes. So no, this is kind of a better together story rather than a new silver bullet. This is pick the one that makes sense and adds value.
And I guess it's in some cases maybe even an on-ramp, where you might start with something like container apps, and as you mature and maybe your requirements change, you may end up moving to something like Azure Kubernetes Service to better suit your needs, as you talked about there in that answer, right? About you might have some changing requirements over time as your business goes deeper into this space. But yeah, look,
Absolutely.
any tool that can help people next level their experience is great as far as I'm concerned. Now, one of the open source projects you talked about today was Dapr. So when we talk about container apps, how does that relate to Dapr, and do we need to use Dapr in order to be able to use container apps, I guess?
No, look, you don't need to use Dapr with container apps, and conversely, you don't need container apps to use Dapr, right? But it's one of those things. It's a peanut butter and jelly situation, right? Individually great, but put them together and super powerful.
Amazing.
Yeah. Oh, look, they're solving different problems, right? The container apps is about simplifying, the platform that's running on, and Dapr is about simplifying the development effort. So they, again, better together, but yeah, you can absolutely don't need to use both together.
And I love that sidecar model of Dapr is really great as well, because it doesn't matter what language you're building your services in or your solutions in, you can benefit from having Dapr available to you to use internally in your apps.
Absolutely. And it means you can also adopt bits and pieces. This is not an all or nothing proposition with Dapr. Just like anything else, it's an API, right? So you can just use what you need when you need it.
All right. Awesome couple of questions there. We are going to hop over onto the live Q&A right now, so please do hang around for that. Todd's been awesome chatting to you during this segment of the show, and I'll see you in a few seconds.
Sounds good.